what we were discussing is about LSA, Link-State Advertisement. Okay, it's just going to update only the link information. And these link information are getting updated in a database. We call it as Link-State Database. Okay. Okay, and all routers maintain a synchronized identical copy of this linked state database for the same area. For each area, it's going to be same. Okay. And the LSDB, what is going to provide actually? LSDB is going to provide the topology of the network. Okay. It is actually acts as an essence in providing the routers a complete map of the network. Okay, so so we will not be able to see exactly, we'll be able to see only the output. Like, okay, so and so network is connected, so and so network is getting this next op and getting connected to a different network. Likewise, the database is seen for us. But for OSPF, in order to router, it understands as a topology diagram of a network. It gives a complete map of the network, this LSDB, link state database. So all OSPF routers runs a it's not coming. Dijkstra shortest path algorithm. That is the link state routing protocols algorithm. Based on this algorithm only, it is constructing a loop-free topology to find the shortest path. Okay, I must have. This is just an algorithm, a predefined algorithm, which actually the OSPF router uses. Okay. So this algorithm, based on this algorithm, based on the programmed algorithm, this OSPF is constructing a loop-free topology to identify the shortest path. Okay. So dynamic only, we are not going to do anything. Manually configure and all. Okay. And so each router, it's going to act as a root or the top. So like what I mentioned, the topology. So when it is creating a topology by itself, so there's going to be a router on the top. So obviously a topology of any network will be like that only, no? So there will be core, router, access, distributed layer, something like that. So OSPF also does the same thing. So it elects as one router in the top, okay, and other routers and all to in the access layer, like how we see in the switches. Like it will have a topology created by itself based on the LSDB that uses to calculate the routing. Okay. So this OSPF is again a widely used supported protocol. Okay. So how it's going to form the neighborship between its adjacent routers. How neighborship, what criteria it uses them to form the neighborship. So when two routers should be running OSPF on the same link to form the neighbor relationship. So it has to be connected through the same link. There should be a physical connectivity between the two routers first. Okay. So when the two routers are physically connected between each other, what are the criteria it's going to match? Okay, it's going to match the area number. Okay. It's going to match the subnet. Mummy, Nanny. Okay, it's going to match the subnet. It's going to match the hello and dead interval time. So if two routers are connected between each other, each router hello and dead interval timer should be same. Okay. And then it should have a unique router ID. So router ID should be unique to each, each router has its own unique router number. Okay. Router ID should not be the same. Its autonomous number should be the same. Okay. So these are the criteria actually router matches before each router should match before it forms the neighborship when it runs an OSPF routing.
The AS number should be same and the area should be also same.
AS number should be same, area should be same, router ID alone should
Is different.
be different.
What about process ID?
Both are same. Router ID, process ID, both are same.
Okay, yeah, got it.
Okay. So this is forming neighborship. So the neighbor routers actually swaps or exchanges the LSTB information between each router that we have already seen. And each router chooses its best path, and that best path alone is getting added in the routing table based on the information that is learned in the LSTB, Link-State database. So Link-State database might have the link status, complete link status of the router, whatever link it is running, what is the status, what is the link speed. So it has the entire information. By checking that LSTB, it actually chooses only the best path, and that the best path alone is getting added in the routing table. Okay.
How to check LSTV?
Yeah, I'll show you. Okay, I'm just explaining the terms alone. And when we go step by step, we will see it. Okay. Next. So, then state. Okay. So requirements to form the neighbor adjacency. So what we have seen, the router ID must be unique between two devices. Yes, there should be a unique for the entire routing domain that prevents error. Yes, okay. Routing, we have seen. Apart from that, what we have seen, hello and dead interval timers should match. Okay. The area, it should match. Okay. Apart from these, there are other default values which also should match. That is the MTU, maximum transmission unit. These are all default values only. Until unless if we modify something, it will change. But but otherwise it is same. Okay, we need not going to touch anything, MTU and all. The authentication or any credentials which we use, that is also like MD5 algorithm, they will use some authentication some type. But so far, I've not seen anybody using those authentications and all. But if we are going to use any authentication type, then it should be same on both the ends. And if we are having any area flags, area segmenting, when we segment area, if something is there, that should also match. So these and all will be discussed later, no, in these things. But when you configure, make sure the router ID should be unique, area should be same, hello dead intervals are same. That's it. The other values and all are default only to form a neighbor adjacency. Okay. Next, some of the OSPF packets. OSPF packets. The first is the allo packet. So allo packets are the packets which actually is for discovering and maintaining the neighbors. Okay, so these packets are used to discover the neighbors. Is there any neighbor available? Okay,
Okay. Can
and
you type it down?
yeah, hello packet. So by the word hello itself, you know. So it is just checking, is there any neighbor available? Yes. If the neighbor is available, is the neighbor is live all the time? Is it alive all the time? So for initially, I don't know who are the neighbors. I might have one router, one neighbor, or 5 neighbors. How do I know how many neighbors are available? So I'll send a hello packet on all the directly connected interfaces. The router have multiple interfaces, WAN interfaces, right? So it keeps sending the hello information on all the interfaces. If it is getting a response to the hello, okay, it has a hello. The other router also will give a hello message. And after getting hello message, on a periodical time of say 10 seconds or 30 seconds, it's keep on going to check if that router is still alive. If the router is the router is up or down. So at that time also it's going to keep on sending hello message. So discover and maintain the neighbors. Okay. Then is database description. It's again a packet type. Okay. Okay, so these are the packets for summarizing the database contents. So packets are exchanged between the OSPF neighbors. Okay, initially it is packets are getting, the packets are getting exchanged between the neighbors, okay, to form the adjacency. Yes, that is done. And these packets are used to describe the contents of the LSDB. What actually LSDB contains? It contains the link state. It contains the summary of the database. That as a whole, as a packet, we call it as database description packet. These packets and all are being sent and received between the neighbor routers running in OSPF in order to form the routing table, or in order to keep alive of checking the adjacency of between the routers. So these things and all are happens when these packets are getting exchanged. Okay, so database description is nothing but the summary of the LSDB. We already seen initially, right, in the term LSDB, linked state database. So it's the summary contains, it is going to get exchanged. Fine. Next,
Okay.
sorry,
Can you type the definitions? I'm unable to follow.
hello, you want to type a?
Yeah, anything, whatever you're saying, just after explaining this, typed it down. It will be easy for me to know.
Okay. Okay. Summarizing the okay. Next, LSR. So LSR is link state request. So these packets are of the database when the router thinks that the part of its database part of the database type, it's the neighbor's database by using the packet type. So LSR request. So what LSR request is actually does is it is a packet of the database downloads, whatever link state database we have seen, it's the downloads, and it is getting sent before, like the database is getting sent, but it is also asking for link states request from the neighbor router. So when the neighbor router sees this message, link state request, then it is sending its neighbor's database by using this packet type. Got it? So my router, I'm just advertising my LSDB. Okay, LSDB is link state database. How I'm advertising? How I am advertising this link state database with the help of database description packet is sent to the neighbor router. That is nothing but the summary of the database. So I'm sending this information to my neighbor. And in turn, I am also requesting LSR, link state request to my neighbor. So I sent my information. I need your information. I need your database. So LSR packet is sent, is just a packet of a request type. It is sent to the neighbor, okay, sent to the neighbor asking for its neighbor's database information in a packet type. So it's a small piece of packet asking your neighbor information. That is LSR. Okay. So that is nothing but a request sent to receive neighbors database. Okay. Then LSU. LSU is link state update. Now, initially it sent a request. Now it is sending a update. So these packets are again a database updates. Okay. So that's normally sent to the direct response to your request. So I have sent one request, right? So in response to that request, I'm getting back the information about the databases, link state databases of the neighbor router. So that packet is called it as link state update. Okay. Response to LSR. Clear? is link state acknowledge. So these packets are of flooding the acknowledgements through all the response sent. Okay. Making making like it's a reliable connection, reliable transport connection is happening. So I sent a request. So I asked some information to you. Okay. And in turn, you are replying back to me. But how do you know that that reply message is received by me? So I in turn acknowledging that information through a link state acknowledge packet. Okay. So I'm saying hi. You're saying hi, how are you? But how do you know that how are you message is received me? Or I know that you have asked for how are you to me. I should respond, right? Or I should acknowledge you, right? Yes, I'm fine. So that acknowledgement is being sent. So it doesn't contain any information. Now this acknowledgement packet does not going to carry any information, but it's just an acknowledgement, a small piece of packet. This is getting flooded to all the responses it's getting, update it's getting. It's just like our TCP connection enabled with the three-way handshakes response, right? Similar to that. Got it? It's just making, and this acknowledgement is made to just a reliable transport feature. Saying, okay, the connection or the path between the LSR, LSU, and the acknowledgement, the path which is going in order to exchange the database information between the routers within OSPF is reliable. Got it? That is the link state acknowledge. Fine. You're clear with the OSPF packets?
Yes, ma'am.
Oh. So these are all the terms which we used. So what you see, this is, if we understand these terms, no, then whenever if we go for explaining some routing concept, then we will just say LSR, LSU being sent, LSDB, LSA. There are 7 types of LSAs actually. So those things and all we will learn in the future classes. So LSA advertisements, link state advertisement has been classified into 7 types based on within the region or within a different region in the sense within the area or within the different area, or only the link, or it sends only the link status. There's one LSA now which sends the neighbor information. So likewise, we name LSA1, LSA2, LSA3, and LSA7. So 7 types of LSAs are there. So now you know what is LSA. Now when we describe all the 7 types, you will be more clear. Okay. So for today, I think it is okay to stop here. Okay, tomorrow we'll see what is available in the OSPF allow packets. Okay, how the neighboring is formed. So when the neighbors are found, what are the steps each router undergoes? Okay, and we'll go on in more OSPF concepts tomorrow.